Hey, this is Pop Culture Petri Dish. Hello, I'm Epperson, and I'm here with my co-host,
Cristian Ramirez.
He's the science guy. I'm the jokes one. Maybe, I don't know. You're better at, you're good at jokes.
Thanks, I appreciate that.
And sometimes
you're good at science. Yeah,
so I don't know why I'm even talking right now. What are we talking about? This is episode 5. What is it?
Yeah, today we're going to talk about spaceships. Yeah, we've talked a little bit about like the Fermi paradox and where the aliens are and other stuff like that. So now we're going to talk about the kind of spaceships that might get us to other planets,
like the design of them,
right? Exactly,
and what they look like, and so what do they look like? So, because I super want that spacefaring to be a thing. So, like, how do we do this?
Yeah, it's certainly, I think, not going to look like anything that we conceive of nothing that we've already conceived of. Because like the Enterprise, it's a huge amount of weight that isn't involved in the actual fueling part of it. And so that's one of the biggest hurdles to overcome when it comes to space is the thing with propellant. Propellant, because it has its own weight, it is already limiting what you can do with as far as distance is concerned. Because the rocket propellants that we have right now, there's no way that they're going to get us to another star system.
No.
The only way that it could is in hundreds of thousands of years, and we don't have technology to keep us alive for that long. So it's not a practical means to do it. The only way that we're going to make it to other star systems is if we basically have to get to 1/10 of the speed of light. And then it's going to be manageable for us to actually travel to the near systems.
That doesn't seem fast at all. Wait, what is the speed of light? 300,000 meters per second?
300,000. I thought it was 300,000 kilometers per second.
Holy.
So
yeah, no, that's more. That's a lot more, right?
Yeah, so it's 300,000 meters per second.
Yeah.
So and that's
so 1/10 of that is like, could I, like, is that like can I do that on a bike? Like, am I fast enough? Is that Usain Bolt's like time?
Sure.
Yeah. So we need to we just all need to be Usain Bolts.
Just a bunch of Usain Bolts running to Alpha Centauri.
So obviously this is a crazy amount of speed and velocity.
Right.
And if you have any weight, all of it's in fuel.
Yeah.
It's like we need like all fuel, zero ship.
Right.
What does that look like?
That's well, let me explain the theory of relativity real quick. And I can't explain it all, but just how it applies to this. The equation of E equals mc squared, where energy is E, mass is m, and then c squared is the speed of light squared, meaning that if you accelerate anything to the speed of light that weighs anything, if it has any weight to it, it becomes energy. It is impossible for material things to accelerate to the speed of light. And because of the squared, it becomes more and more difficult the more something weighs to accelerate it at anything approaching the speed of light. So the way that we're going to, overcome things like this is that in space, there's a couple advantages that we have. There's no air resistance. There's nothing resisting.
It's a vacuum.
Yes, exactly. So any kind of spaceship that we send up there, once it gets into space, there's nothing. We just got to point it in the direction that we want to go, and there's not going to be anything that slows it down.
This just sounds like just a clown car of like if we're still working these things out, like we don't deserve to go anywhere. Because like what we're working out is like, all right, so just like put me in a chair and just throw me at the cosmos and hope for the best. Hope for the best. No, we need to work out, like, spaceships need to work out like navigation before that they can do like these kinds of speed.
Yeah, we need a braking system.
Yeah.
For when.
Yeah, because right now all we're doing is we're just putting liquid dinosaurs in a just a tube.
Bullet. It's basically
a bullet, and just scream our way into space. Like that is what rockets are. Right?
Yeah.
Just like fuck, and we're barely able to get off this rock.
Right.
I mean, obviously we've had a long-standing tradition of doing it for 50, 60 years, if not more, and that's great. But if we want to be spacefaring, we got to figure out just roaming around our backyard before we can even think about going to Alpha Centauri or anything.
Right, exactly.
So,
and one of the ways that they do it with satellites and stuff like that is that they have little jets, and they're not exactly jets because they basically displace enough air and matter within they give us enough of a pulse that it turns, it rotates, or it moves the satellite within space. So that's kind of how they steer, because the way that we understand steering on Earth is basically through the use of resistance by either us on the ground when it comes to cars or through the air when it comes to planes. There's none of that in space. So basically we just have to have a bunch of little propellants that will turn, rotate, and spin whatever it is, whatever kind of satellite it is in space to do that, because there's no way that we can create those forces through drag to kind of orient ourselves in space.
Oh, gotcha. Yeah, because there's no atmosphere.
Right, exactly. So that's kind of how our brakes are going to have to be too when we're
screaming into space and going, fuck, stop. Yeah, no, how do you brake in space? You have to just do equal amount of propulsion in the opposite direction, right?
Yeah, you do small pulses of propulsion to slow you down little by little, because you can't just turn on a rocket engine that's the same force as the one that got you into space, because that'll kill you from the G's.
You can't just put your arm out of the spaceship and grab a moon and just hold. Yeah, no, it doesn't work. So braking is one of the biggest problems.
Yes, it's a challenge.
That goes along with intense amounts of speed.
Right.
We don't even know how to get the intense amount of speed. And then even if we did, how the fuck do you stop? Because you're just you're just gone.
Right. There's a certain amount of the planet's gravity wells that we can use to slow us down. But of course, if we're going too fast, those just basically work like a sling and direct us in a different direction.
I had a conversation with my mom because we saw ISS.
Yeah.
It was a year or two ago. We were just outside and it was a dark night. And I saw on Reddit, they were like, oh, over Southern California, the ISS is going to be there at this time if you want to see it. And I was like, I want to see it.
Yeah.
And she looked up and she saw it and she was like, wow. So there's people in there. I was like, yeah, there's 12 people living there.
Yeah.
It's crazy, huh? And she's like, yeah. What's the furthest thing that we sent to space? And I was like, well, that would be Voyager 1.
Yeah.
And she's like, when's that coming back?
Never.
And I was like, oh, Mom, no, it's not coming back. We just we just threw it screaming into space and put a photograph and said hope for the best, buddy. If you find anyone, here's a way that they know where we are, but we are never going to see this combination. Voyager's gone.
Yeah.
And it's she for some reason thought that anything we send in space goes in orbit.
Right.
And I was just like, nah, man.
No, once it hits escape velocity.
Mom, you're so smart, but this just shh.
Voyager maybe will run into something eventually, because that's another thing about space that we don't really conceive of that well, is that the distances are just so vast that Voyager 1 probably will never run into anything until the end of the universe.
So that whole idea about how, was it Spirit or Opportunity? No, it's Curiosity. Man.
Yeah, Curiosity.
Curiosity sings its happy birthday song every year, to itself.
Yeah.
Because it makes sounds through the rotor control.
Right.
So it can dun, 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 dun. And everyone's like, that's the saddest thing I've ever heard is a robot on Mars singing happy birthday to itself. That's so sad. And I'm like, I think about, I'm like, you think that's sad? Have you heard about Voyager? It doesn't even have the ability to sing happy birthday to itself. It's just screaming in space like, why? But so if we want to cut down like the idea of time,
right,
we need to find out how like warp drive happens. And all of warp drive and all of science fiction is, I mean, that's where it's fantasy.
Right.
Because it's just like, even like you have to suspend your disbelief in Star Trek, which is like a pretty good TV show for hard sci-fi.
Yeah.
Except for the fact that you just have to like kind of give up, like, oh, what's hyperspace? Which is the thing we made up. Just run with it. And we're like, okay. But as long as you're fine with these other things,
right,
just believe this.
Right.
So all of our sci-fi kind of has this, like, you know, to use a science term, like this dark matter, this dark energy, this question mark of what going the speed of light could do.
Right.
So you're telling me we haven't found that?
Not yet. There's a scientist whose last name was Alcubierre. He talked about things that bear his name now called Alcubierre warp fields, which basically you have a spaceship, which is like a couple of rings around something that's shaped kind of like a cigar. And they would generate a kind of force which bent space, which would bend the fabric of space. And that's a weird sounding concept because space is a vacuum.
So this is like general relativity shit?
Yeah.
Yeah.
It's relativity stuff that they used the theory of relativity, worked backwards using math, and said theoretically we could do this to space.
If we had something that would create energy, or
it has to create the right amount of energy, and it has to be directional too, because what it does is that it basically bends space into a waveform to where space is stretching out behind you and it's bunching up in front of you, so that if you are traveling at a certain amount of speed, you're actually technically going faster than the speed of light, but you're not, because you're just bending the fabric of reality enough to where you're moving. It's the idea of using a pencil. If you put a pencil on top of a piece of paper flat, then it probably won't reach the whole length of the paper. But if you bend the piece of paper, then you can put the pencil through it.
Yeah.
And it'll reach the entire length of it.
Yeah. Every space movie does two things.
Yeah.
They show that the pencil through the paper. And the other thing is any time in space where they're like, we need to pick up speed. And The Martian is the most recent one of it. It's like, we need some serious out of the box thinking. How are we going to do this? And it's like, we could use a slingshot.
Yeah.
And just use the gravity. And they're like, I didn't even think of that. And it's like, I was talking to my friend who works at JPL, and he was just like, he hates that trope because he's just like, it's literally the first thing that anyone can talk. Like, it's the only thing.
Right.
Like, so whenever Donald Glover is like, I know what we can do. We can use a slingshot, use the moon, or whatever. And he's just like, yeah, no, that's the top of the list. There's nothing out there. It's just a bunch of nothing.
The only way to propel you is with gravity.
Yeah. So, although I love this Alcubierre. Is that his name? This Alcubierre guy. Because I feel like when he was coming up with like his dissertation or his thesis, they were like, this guy's smoking weed. He's like, if we just spend a little bit of effort, we can bend space-time and warp. There's a warp field. And it's just like, okay, well, you're high. But that's just me because I'm just a layman. I don't understand.
Yeah, that would be...
I'm sure he's a very, very smart man. Way smarter than I am. And knows the physics he's talking about. But, like, how do you bend space-time?
I don't understand it completely either.
So
basically, it's only a theory in math right now.
Yeah, and it's like...
And that's where it starts.
You have to assume that this, like, rings around the cigar thing you're talking about is, like, has enough gravity? Like it has to change. Like it has to be very dense or something. Right?
It's changing,
which it goes antithetical to the thing you were saying before, where you don't want things to be heavy. Yeah. But as we learned, because mass is the worst part of that equation. But it seems like mass is the thing that allows things to bend.
Right. Exactly.
That's the Higgs boson. Right?
Exactly. That's what we use. That's what's going on in a black hole, as far as we understand, is that it's so massive that it's bending light and space and everything around it. And
so we need black hole drives.
Yes, that
sounds very dangerous.
It is. It would be very dangerous. There's actually, that's one of the ideas. I don't know if this one's actually called the Kugelblitz drive or not, but I know there was another
Kugelblitz?
Yeah. There was another, it's a German scientist who came up with the idea.
That's not a German name at all. Kugelblitz.
But yeah, he came up with the idea of using he either came up with the idea of using antimatter or a small black hole to propel us through space.
Now there's are you familiar with this thing called the Schwarzschild radius?
It sounds familiar.
From what I understand, or Hawking radiation.
Yeah.
RAP, Stevie. So apparently there is a like when we talk about like a star going supernova.
Right.
There's a magical number for when, like, whether or not it folds onto itself and creates another star or it creates a black hole is determined by the radiation. Like, so it's being put out and that's just now gone.
Yeah.
Versus there's like from what I understand, someone in comment will probably be like, AB, you do not understand these Hawking radiation. And I'm like, yeah, you're right. I don't. But I just read this thing. So here we go.
Yeah.
And there's this magical kind of boundary where it can become a black hole,
right?
Which takes a lot of mass.
Yeah,
you know,
basically what's going on, what you're talking about, I can give a quick rundown of it, is within a star of a large enough mass, all stars are burning hydrogen. They're giant hydrogen reactors. So within the core of a large enough star, the mass within it creates enough gravity to where hydrogen starts bonding and becoming helium, and then it bonds until it gets to iron, and that is when it has the potential to create a black hole because it's so massive.
Is that always like? Is that how we categorize stars? Like, if it makes iron, does that mean it's like a hypergiant or something like that, or is that more based on like the distant, like the enormity of the star?
Right. There's a bunch of different ways that we classify stars because once they get to a certain size, they're different sizes and colors, which means that the reactions that they're going on. So we have a
yellow dwarf.
Right. I don't even think it's a dwarf, but it is it's a yellow star, because we have things like white dwarfs, which are much smaller than our sun, but also like they're the remnants of old stars. White dwarfs can burn for millions and millions not millions, billions of years, and they will be the last lights in our universe, basically, are white and brown dwarfs, because they don't...
It's pretty racist. just putting that out there.
It has to do...
Get woke, stars.
With the way that they... Basically, it has to do with the efficiency of their reaction.
Okay.
The larger the star is, the more inefficient the reaction tends to be, and so the more violent it is. You can get gamma ray bursts and black holes out of the really big stars. And the smaller ones run really efficiently, so they last a long time.
So it's like a low simmer versus a very, burning hotness. I feel like I'd be burning hotness.
Yeah.
There's nothing about me that is simmer. But that has nothing to do with what we're talking about. So Kugelblitz is saying that we create a drive out of like a small version of a star folding upon itself.
Right. It would be like a little tiny ball of lightning that you shoot. Basically, the theory is you shoot enough energy and lasers into a small enough area that basically creates enough energy to form a tiny reaction where it creates a black hole it would be insignificant, obviously, because it can't be too big and evaporate, or it'd be too small and not produce energy. It would have to meet exactly the right balance to where it would power the spaceship that we would be using to get to this is for long distance star travel. This is something that, because it's a little black hole and it has a time period, it would have an expiration date too. It would take like something like 3 to 5 years for it to evaporate. But in that time, it can get us up to potentially like 50% of the speed of light.
Jesus.
So, yeah. So using all of that energy would be able to help us traverse huge distances in the galaxy.
And that's still like, that means that, like, what's the close? How many light years is the
I think Alpha
like?
Centauri is 4 light years away.
So that would still take us 2 years to get there.
Yeah. Well, it'd take us 8.
Oh, 8. Yeah. Sorry.
Yeah. But
twice the speed
that's
of
still
light.
obviously like that's doable for a human. Whereas if it's 4 light years away and we're only going 1/10 the speed of light, then it takes us 40 years.
But here's the thing though, is you need to put a crew up there or robots.
Yeah.
And if it's a crew, there's like, you need to have a hyper sleep situation, right?
Yeah.
Because people would go crazy in over 8 years and murder or fuck each other. And we got to just turn that off.
Yeah.
Our own biology.
Yeah. And essentially, it's going to take so much energy to do something like that the ship would have to be so massive that it would be built in space, and it would have to be built by an international community. And it would only have a little tiny amount of room for the living quarters, because we need all the fuel and energy that we can put into the actual propellant. One of the other, this one's just kind of a cool, crazy version of the kind of propellant we could use, is that we are very good at making nuclear weapons. We're very good at making bombs, which if you set off a nuclear weapon in space, it still creates...
It's awesome. Is that your point? Is that it's awesome? Because that's what first thought of.
It is, but it also, it creates so much energy that we can actually ride the wave of the nuclear energy in a space.
Fucking Point Break, yeah, dude.
In a spaceship. So one of the ideas, and this is basically because we're so good at building nuclear bombs. One of the more practical, not practical, I don't know how to put this, but as one of the things that are actually doable that we could do is have a ship with our most advanced nuclear weapons, and it's just dropping bombs behind it and riding the wave.
Fucking amazing.
Of the nukes to whatever destination that they're going to. And that could potentially get us to 1/10 of the speed of light.
Did you ever play Quake when you were a kid?
I did.
Did you ever use the rocket jumps?
Yeah.
Like, that's what I imagine. Like, you just like jump and then fire the rocket, and then like it's an explosion that would kill anyone nearby and also would throw you halfway across the map. Like, I imagine that's what is this why we become scientists, so that we can ultimately just drop bombs in space and drive real fast? Because it sounds like you're all a bunch of Ricky Bobbies from Talladega Nights.
Yeah. But
just like, I want to go fast. Yeah, no, Jesus, that is an insane prospect, because that means you need to have all that ammunition.
Yeah.
Like, your fuel is just highly combustible, and like anything goes wrong, like you're like, well, here's the problem: a tiny fire happened, and now there is no more Earth.
Yeah.
So we shouldn't be fucking with that, right? Like, maybe we should just like find a way to get to Mars and be cool with that.
Right. It is one of the things we definitely should be focusing on our local. Our solar system, because there are planets out here that we could potentially colonize. But and I will bring up one more version of one of the drives that we could use to traverse the stars, and it's an antimatter drive. Basically, the way that nuclear explosions work is it's using matter and fusion to create a reaction that releases a ton of energy.
And what's the difference between fusion and fission again?
Fission is splitting atoms apart.
Fusion is
pushing them together. And fusion releases more energy. The thing that releases even more energy, it's the most energy efficient, theoretically, the most energy efficient thing that we can do is create enough antimatter to combine with matter, and then basically it creates an explosion that is even more energy efficient than a nuclear weapon.
Yeah.
And that's just using tiny amounts of antimatter and regular matter. So basically what we do again is with that one, we could actually create like a jet that uses an antimatter matter reaction to propel us through space. So once again, I mean, any kind of rockets that we use now are basically harnessing explosions to propel us.
Yeah.
And so this is just
screaming into space.
and so this is just the most efficient version of that. But we don't have a good way of creating antimatter. Like the best way that we have right now is in the Large Hadron Collider.
Yeah.
And even then it's only tiny amounts, and the antimatter that we do create eventually dissipates and gets destroyed with just being introduced into an environment that has regular matter, which is all around us.
It's a goddamn shame there isn't any antimatter mines. You know, like in October Sky, I think Chris Cooper's character is like, I just gotta go down into the earth and get that antimatter so we can go to space. Wait, no, I'm confusing so many things. I love that movie.
Yeah,
that movie's
a good movie.
One of the reasons I became a storyteller.
Yeah,
it's such a fucking good movie. But okay, so we have Kugelblitz, the most German of all the drives. We have black holes.
Yeah.
We have Alcubierre warp fields.
Yeah.
I heard something you mentioned earlier about light sails. What is that? That sounds awesome.
Yeah.
And can I ride one?
That might be the way that you get to another planet, because
How does that work? So it's like, I imagine sails. It's like there's no wind.
Right.
It's replacing wind with light. So is it essentially a receptor of light, and that how does that power? Like, how do photons?
Yeah, it's
power. Because I know photons are energy.
Yeah.
There's that whole wave duality thing, but how do we use that?
It's super thin material that this is another one that I think this is one of the ones that we've actually made the most progress on using. Everybody's seen Star Wars. Count Dooku's ship has a light sail, and one of the I was just saying Count Dooku.
No, I'm sorry. I just can't. I can't allow Count Dooku to be a thing. That just doesn't make sense to me. Continue.
But he did have a ship that used a light sail for long distance travel, and it's harnessing the energy from it would essentially just be like paper thin solar panels that harness energy from whatever star is the closest by, and it converts all of that into the energy. And there's obviously other types of radiation that the sun releases. There's
light,
right?
Still,
right. But ultraviolet is the most energetic type of light, and we can't see it. That's the kind of stuff that it's the hottest.
And
it's what creates
radio
heat.
waves on the other side, X-rays, gamma rays.
Yeah.
These are all light.
Yes.
Okay.
They're all different waves, and so we'd basically be using something that captured all of that energy and used it to propel us, and all of those different types of energy would propel us towards wherever we're going. Once again, there's a braking problem with that, because we can ramp up to the speed of like 1/10 up to, and I think they said up to 1/3 the speed of light within like a few years. But once we get up to that speed, how do we slow it down? We're going to have also a sail that we deploy behind the ship to slow it down enough to land wherever we want to land.
Or just Chris Cooper goes down in the mines and gets anti-light. Yes. To reverse light. I don't know what I'm talking about. Nothing makes sense. No, that's fascinating shit, man.
Yeah.
The idea of catching solar rays as a way of traveling, and that's like the best thing we got right now.
That's potentially one of the best things that we have. The Kugelblitz drive using a black hole, antimatter drives is something that we could theoretically do now, but creating antimatter is hard. once we figure out a better way to do that, then we could probably do it.
I assume that at any time someone has a scientific breakthrough that just changes all the games.
Yeah.
So there's always that contingency.
Yeah.
But that's not a good way to operate.
Right.
When we talk about like climate change, once again to bring up my parents, I think it was like during Christmas, I was just like, I'm pretty like deep into the idea of like environment is like my main issue of voting.
Yeah.
And they were like, oh really, why? And I was like, you know that like coral is already like on its way to being extinct.
It's
like,
gonna kill us
in 20 years. Finding Nemo is gonna be a period piece.
Yeah.
And they were like, oh wow, you really strongly feel about this. And I was like, yeah, I do. And they're like, well, I mean, we lived in the society where that would like since the 70s, that's like been a big deal.
Yeah.
And every time because they live through like chlorofluorocarbons and like eagle eggs shattering because of like the things that our refrigerators and shit like that, like just using toxic chemicals. And then we had a breakthrough and decided to stop using them. So everything that they know is that they'll just be a breakthrough and it'll be fine. That is not a good way to operate.
No, we need to conserve now and
so like
be precious with our resources.
We're like, we gotta get traveling to other planets, and we're just like, I don't know, we'll just figure it out.
There's one thing that you mentioning this made me think of, and it's the concept of a weight calculation, and that essentially is the fact that technology is always improving currently. So if we wait X amount of years and develop a spaceship that can go faster, significantly faster than what we have now, then it'll end up making the journey quicker faster than the one that we sent today. Yeah. And I know that's something that gets brought up in a lot of sci-fi. I think, did it get brought up in Ender's Game?
I don't know.
But I know
it
that
might be in Speaker for the Dead.
Okay.
Because he has he literally has the whole age problem. Mm-hmm. Like he goes to, because of general relativity, he essentially stays the same age, and then he like contacts through the galactic Ansible, which is this fictional thing in Card's world where he's like, oh, at any time that you can talk to one another, like there's a phone service in space. Mm-hmm. And he talks to Valentine, who's his sister, and she's like 80 now. Oh, okay. And that's like Interstellar. Yeah. He like outlives his daughter.
Yeah, that's another problem, because if you travel at close enough, at factors of the speed of light, then you age more slowly. Yep. Because time, that's just how time and velocity.
Time dilation.
Yeah, time dilation is a very real thing once we start getting up to speeds that fast. Mm. It's a real thing now for people that spend enough time in space, but it's not an extreme thing. Like it's
because we're not yet going that fast.
Right.
Although they're like, aren't astronauts' bones like no good? Like they're bad bones.
I think that has more to do with gravity.
Okay. But so I'm mixing my principles. I think that's a good place as any, where Abe says astronaut bones are bad, and you're like, no, Abe, you're an idiot. I feel like that's a good ending of this episode. So any last final words before we scream into space?
I think we definitely should wait at least long enough so that we don't have to scream in space on the wave of nuclear weapons to get to Alpha Centauri.
Just bomb our way to everything. Some alien is just like, are they using bombs? Is that how they're getting through? Because we just use space energy. And they're like, well, what the fuck is space energy? It's like, not bombs, you fucking cretins. All right. Thank you for joining us. This has been episode 5 of Pop Culture Petri Dish. Yeah. Starring my friend Cristian.
And my friend Abe.
I am also here. The dumb one. All right. Thanks, guys. See you next episode.
This has been a Small Beans endeavor. We're a bunch of pals who make podcasts, sketches, music, web series, and movies. The beans always have new ideas percolating, so make sure to check us out at patreon.com/smallbeans. That's patreon.com/smallbeans, where you can browse all of our current and past content, see what we've got planned in the future, and learn how your support can help the small beans grow into huge, giant monster beans. If you enjoyed this content module, please like, rate, subscribe, or tell a friend about us. We love you!